Hey students, this is lesson 10.3, operations with radical expressions. We're going to learn how to simplify sums and differences of radical expressions and to simplify products and quotients of radical expressions. There's an important word here in the vocab. Make sure you take a look closely at that. According to the distributive property, number one, the problem that correctly uses the distributive property is D. And the vocab, the conjugate, are sums and differences of the same two terms. You're going to find out in a little bit why they're important here. But so you have the same two terms, it's just that one is sum and one is a different. So A minus B and A plus B would be considered conjugates. And when you multiply conjugates, you get difference of squares. So if we multiply A minus B times A plus B, we get A squared minus B squared. And that comes in handy when you're simplifying radical expressions. So the conjugate of each of these, square root of 2 minus 3, would be the square root of 2 plus 3. Square root of 2 plus the square root of 3 would be square root of 2 minus square root of 3. 2 plus the square root of 3 would be 2 minus square root of 3. Square root of 3 minus 2 would be square root of 3 plus 2. All right, we're going to simplify radical expressions. Just like when we're simplifying other expressions, we're going to look for like radicals. When we have like radicals, we can simplify them. When we have unlike radicals, we can't. So it's similar to this. Like if I had 3x and 7x, I would say they are like terms. And if we had 3x and 7y, we would say they're not like terms, unlike terms. So like radicals and unlike radicals are similar to that. So if they have the same exact square root, then they're like radicals. So we have that here. These are like radicals, and we're going to simplify that. And I'm going to use the distributive property to do that. This is equivalent, according to the distributive property, to 2 minus 6 in parentheses and then times the square root 11. So the square root 11 is distributed and multiplied by both 2 and 6. And 2 minus 6 is negative 4. So I can just write that as negative 4 times square root 11. We can do that here also. We can do 4 plus 4 times the square root of 13 using the distributive property. And then just write that as 8 times the square root of 13. Remember that if you have an expression without a coefficient, multiplying by 1 means the same thing. So this is the same as 1 minus 4 times the square root of 7 using the distributive property, which is negative 3 times the square root of 7. So that's how you do those, as long as you have like terms. I'll let you try one. All right, what is the simplified form of 7 times the square root of 6 minus 2 times the square root of 54? Right now, they're not like radicals, so we can't use a distributive property on them, but you should also notice that square root of 54 is not simplified. So let's rewrite 2 times the square root of 54 like we learned to do in the last lesson. The greatest perfect square factor of 54 is 9, so we're going to write 2 times the square root of 9 times the square root of 6, and that's equal to 2 times 3 times the square root of 6, which is just 6 times the square root of 6. Now I'm going to replace that, and instead of 7 square root of 6 minus 2 times the square root of 54, I'm going to subtract 6 times the square root of 6. Now we have like radical terms. And I can use the distributive property, and that's equal to 1 times the square root of 6, which we'll just write that as square root of 6. All right, I'll let you try that. All right, well, what is the simplified form of each expression here? We're doing some multiplication. For the first one, we're going to take the square root of 5 times the quantity square root of 8 plus 7. That looks like a place for the distributive property. So I am just going to multiply that out. square root of 5 times square root of 8 is the square root of 40, according to the multiplication property of square roots. And 7 times square root of 5, we're just going to have to write like that. Now we're going to simplify the square root of 40. The perfect square factor in that is 4. And that's equal to 2 times the square root of 10 plus 7 times the square root of 5. And those two aren't like terms, so that's all we can do. All right, in this one, we are going to multiply. It kind of looks like two binomials multiplied. So we're going to use a FOIL method here. First, we're going to multiply these two out. And to do that, I'm going to do 7 times 3, which is 21. And the square root of 8 times the square root of 8 is 8. So we have 21 times 8 there. The outers give us 7 times the square root of 8, and that's a minus because we have a 1 plus and 1 minus. We're going to get 7 times the square root of 88. The inners, we're going to get 2 times 3 is positive 6 times the square root of 88. And then the last two would be those two. We're going to get 2 times, there's a negative there, and square root 11 times square root 11 is 11, so 2 times 11. We'll simplify that now, and we get 168 minus, these are like terms, so I can just combine negative 7 and 6. Maybe I'll show that work here still, how we use the distributive property there. So we got negative 7 plus 6 times the square root of 88, and then minus 22. We can simplify 168 minus 22 is 146, and negative 7 plus 6 is negative 1 times the square root of 88. And that can be simplified a little bit. There is a perfect square factor in 88, and it's 4. So let's just put over here square root of 88 is equal to square root of 4 times the square root of 22, which is 2 times square root of 22. And so we get 146 plus negative 2, let's just say minus 2 times the square root of 22. All right, I'm going to pause here. You can try the next problem. Sorry about that long pause. So here's going to be a new one. This is where we're going to use the conjugate to help us out. Remember that to be simplified, we can't have any square roots in the denominator. So we have to think of a way to get rid of those. And I'm not sure that anybody would come up with this way if you didn't see an example. But what we can do is multiply both the numerator and denominator by the conjugate of the denominator, which is the square root of 3 minus the square root of 11. And you'll see what happens shortly. So we're really just multiplying by 1, which won't change it. We'll just change the way it looks when we do that. And when I multiply the top by that, I get this 8 times the quantity square root of 3 minus square root of 11. And on the bottom, check this out. We're going to do the first two. Square root of 3 times square root of 3 is 3. Then when we do the outers, we get negative square root of 3 times square root of 11 is negative square root of 33. When we multiply the inners, we get positive square root of 33. And then the last two, we get square root of 11 times minus square root of 11 is minus 11. And notice these two will cancel, and we get just 3 minus 11, which is negative 8. And when I divide those, that's going to equal -1, so I just get -1 times quantity square root of 3 minus square root of 11, and that wouldn't be too bad an answer. We could distribute the -1, and that gives us a positive square root of 11 and a negative square root of 3. All right, I'm going to let you try that. Okay, so we're going to use some of our strategies here to solve this whole problem here. Painting below fits into a golden rectangle. What is the width of the painting round to the nearest inch? Well, it turns out that the golden rectangle is this, or the golden ratio. It's 1 plus square root of 5 to 2. So if the side lengths are in that proportion, that means that 1 plus the square root of 5 over 2 is equal to, and 1 plus the square root of 5 is the longer side, so that's going to be my 105 over x. Now I'm going to use cross products, and then I get 1 plus the square root of 5 times x is equal to 105 times 2, which is 210. So that means x is equal to 210 divided by 1 plus the square root of 5. And to put that in simplest form, I'm going to multiply by the conjugate, which is 1 minus the square root of 5. The numerator and denominator. And when I do that, I get 210 times 1 minus the square root of 5 divided by, and 1 times 1 is 1, square root of 5 times the square root of 5 is 5, and 1 minus 5 is -4. Now at this point, I'm just going to use my calculator and simplify that. And to the nearest inch, it comes to about 65 inches. All right, I'm going to let you try that. All right, your lesson check. And let's see, what did the student do wrong here? The conjugate of square root of 3 minus 1 is square root of 3 plus 1. Did the student use the correct conjugate? Square root of 3 plus 1, yeah. Did the student correctly multiply the numerator and denominator of the conjugate? Square root of 3 times square root of 3 is 3, not 9. No, it did not. So the error is square root of 3 times square root of 3 equals 3, not 9. And so the answer would be, if we did it correctly, square root of 3 plus 1 over 2. All right, that's it. I'll see you tomorrow.